In this video, we are going to look at exothermic and endothermic reactions. So what are they? How are they different? What about their energy levels? In the next couple of minutes, you'll know everything you need to get started. An exothermic reaction gives off energy to the surroundings, like this fire giving off heat, whereas an endothermic reaction takes in energy from its surroundings, like this poor melting snowman taking in the heat. Just remember, exo means external, so giving out, and endo means internal, so taking in. Let's start by having a quick look. Because exothermic reactions transfer energy to the surroundings, and this energy is usually heat energy, they cause the surroundings to heat up, just like a bonfire, keeping everyone warm. Other examples of exothermic reactions are the neutralization reactions between acids and alkalis, the reactions between water and calcium oxide, and respiration. It is easy to detect exothermic reactions. Just get your thermometer and see if the temperature increases. Watch the hydrochloric acid and sodium hydroxide solution being mixed and see how the thermometer increases. Most chemical reactions are exothermic because heat is given out. Physical processes can also be endothermic or exothermic. When something freezes, it goes from liquid to solid. Bonds need to be made for this to happen. And to make bonds, you need to do some work. Thus energy is given out and freezing is exothermic. Similarly, when condensation happens, because the gas is going to liquid, again bonds need to be made, and so energy is given out. So freezing and condensation are both exothermic. Because in exothermic reactions, energy is given out to the surroundings. This means that energy of the reactants is higher, and the energy of the products, hence the energy curve for the exothermic reactions, will look like this. Now let's have a look at endothermic reactions. These are less common. Remember that endothermic reactions take in energy from the surroundings. Again, as with exothermic reactions, the energy being transferred is usually heat. So in endothermic reactions, the surroundings usually get colder. Again, we can detect endothermic reactions with a thermometer because the temperature would get colder. Some examples of endothermic reactions are electrolysis, the reaction between sodium carbonate and ethanoic acid, and photosynthesis. Endothermic reactions can also be seen in physical processes. When something melts, it goes from a solid to a liquid. For this to happen, bonds need to be broken. And to break bonds, energy needs to be put in, like our melting snowman. Boiling is also endothermic because energy needs to be put in to break the bonds for the liquid to turn to gas. Because in endothermic reactions energy is added to the reaction, the energy of the products is higher than the energy of the reactants. And so the energy curve looks like this. So there you have exothermic and endothermic reactions. All you need to remember is that exothermic reactions give out energy and endothermic reactions take in energy. Both can be detected with a thermometer. In exothermic reactions, the surroundings get hotter, and in endothermic reactions, the surroundings get colder. Exothermic reactions start with more energy and end with less, while endothermic reactions start with less energy and end with more. Freezing and condensation are exothermic because bonds need to be made, which gives out energy. Melting and boiling are endothermic because bonds are broken, which requires additional energy. Think of the snowman again. And finally, exothermic reactions are more common.